Hey everyone, and welcome back to the channel. Imagine, for a single, terrifying second, the world as you know it simply floats away. The coffee cup on your desk drifts upwards, then sideways, accelerating eerily. The very air around you thins, then screams past you as the atmosphere, unbound, begins its desperate escape into the vacuum of space. Your feet, once firmly planted on the ground, find no purchase, and suddenly you are just another unanchored object, a biological satellite in what was once your living room. The sky, a familiar blue just moments ago, darkens to an inky black, peppered with stars that no longer twinkle, but blaze with an unnerving, steady light. This isn't a dream, nor a movie special effect. This is the cataclysmic, incomprehensible reality of gravity, the invisible force that shapes our very existence, holds us to our planet, and binds the cosmos were to vanish. What if, with an instantaneous, universe-altering flick of an unseen switch, gravity simply ceased to exist? The implications are far more profound and far more terrifying than you might first imagine. Today, we're diving deep into that chilling scenario, exploring what would happen in the immediate aftermath, the fate of our planet, our solar system, and ultimately, the very fabric of reality itself, if gravity were to disappear. The moment gravity vanishes, the world as we know it would be utterly and instantaneously unrecognizable. For us, on the surface of Earth, the first sensation would be an overwhelming weightlessness, unlike anything experienced in microgravity environments on the International Space Station. Every single object not actively secured would simply lift off. Your car, your house, even the fillings in your teeth, they would all become unbound. People would float away from the Earth's surface, not into space directly, but into the path of anything else that was also floating upwards. It would be a chaotic, slow-motion demolition derby, as millions of unanchored objects, from pebbles to entire skyscrapers, began to drift and gently collide. The immediate danger wouldn't be falling, but being gently propelled into other objects, or worse, out into the rapidly dissipating atmosphere. And speaking of the atmosphere, this is where the scenario turns truly catastrophic within minutes. Our atmosphere is held to Earth by gravity. Without it, the atmospheric gases, no longer attracted downwards, would simply expand outwards into the vacuum of space. The air pressure would drop almost instantaneously. Within seconds, the breathable air around us would begin to boil away, leading to a rapid loss of consciousness due to anoxia, followed by cell rupture from the sudden pressure drop. The very sky would become a deadly, expanding cloud of nitrogen, oxygen, and other gases, abandoning the Earth to the harsh radiation and vacuum of space. Oceans and other bodies of water would fare no better. Without the gravitational pull, the immense pressure of the ocean depths would be released. The water would effectively boil and freeze simultaneously in a phenomenon known as effervescence, rapidly transforming into a cloud of ice crystals and water vapor, also escaping into space. The Earth would be left as a parched, airless rock in a matter of hours, if not minutes. Beyond the immediate terrestrial chaos, the disappearance of gravity would trigger a cosmic unraveling of unimaginable proportions. The Earth, currently in a stable orbit around the Sun, is held there by the Sun's immense gravitational pull. Without this force, our planet would no longer be bound. Instead, due to its immense inertia from its orbital velocity, Earth would simply fly off in a straight line, tangentially to its former orbit, at a speed of approximately 30 kilometers per second, or about 67,000 miles per hour. It would become a rogue planet, hurtling endlessly into the deep void of interstellar space, a lonely, frozen hulk. The Moon, too, would abandon its orbit around the Earth, similarly hurtling off into the cosmos. Every planet in our solar system, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, would likewise cease their intricate dance around the Sun. Each would shoot off on its own tangent, forever lost to the darkness, never to return. The Sun itself, a massive ball of plasma, is held together by its own gravity. While it wouldn't immediately explode, the strong and weak nuclear forces and electromagnetism would still be at play. Its structure would begin to change. Over time, the internal pressure generated by fusion would cause it to slowly expand and diffuse, losing its spherical shape as the external gravitational constraint vanished. The implications extend far beyond our solar system. Gravity is the architect of the universe. It's the force that caused nebulae to collapse into stars, stars to clump into galaxies, and galaxies to form vast clusters. Without gravity, these structures would slowly, inexorably, begin to disperse. Stars within galaxies, which orbit a central supermassive black hole held by its gravity, would simply fly off into intergalactic space. Galaxies themselves, currently bound by the gravitational attraction between their constituent stars, gas, and dark matter, would start to unravel. The universe, which we observe as a grand tapestry of cosmic structures, would devolve into an ever-expanding, increasingly sparse collection of individual particles and celestial bodies, each moving in a straight line, forever isolated from one another. The beautiful cosmic ballet we witness through telescopes, from planetary orbits to galactic collisions, would grind to a halt, replaced by an eternal, silent dispersion. truly grasp the devastation, we need a brief refresher on what gravity actually is. In the most widely accepted scientific explanation, Albert Einstein's general theory of relativity, gravity isn't a force in the traditional sense, but rather a curvature of spacetime caused by mass and energy. Imagine spacetime as a stretched rubber sheet. Placing a heavy bowling ball, like the sun on it, creates a dip. Smaller marbles, like Earth rolling nearby, don't fall into the bowling ball because of a force, but rather because they are following the curves in the sheet. So if gravity disappeared, it would imply that mass and energy no longer curve spacetime. This isn't just a force disappearing, it's a fundamental alteration of the very geometry of the universe. The rubber sheet would become perfectly flat, everywhere, instantly. This raises profound questions about the other fundamental forces. The universe is governed by 4 known fundamental forces: the strong nuclear force, the weak nuclear force, electromagnetism, and gravity. If gravity vanishes, the other 3 would, presumably, remain. The strong nuclear force binds protons and neutrons together within atomic nuclei. The weak nuclear force is responsible for radioactive decay. Electromagnetism governs the interactions between charged particles, holding atoms and molecules together, and is responsible for light. So without gravity, atoms would still hold together, and molecules would still form. Chemical reactions could still occur. However, the macroscale structures we observe, planets, stars, galaxies, rely entirely on gravity. While a rock would technically still be a rock in terms of its atomic composition, it wouldn't be held to any larger body. You would still be made of atoms and molecules, but those atoms and molecules would no longer be part of a larger structure that is also bound to a planet. Could humanity survive such an event? In short, no. The immediate loss of atmosphere and the subsequent vacuum, coupled with the extreme temperature fluctuations, from the searing heat of direct, unfiltered sunlight to the absolute cold of space, would render survival impossible. Even if somehow protected from the vacuum and temperature, the Earth itself would be hurtling into interstellar space, away from the sun, its primary energy source. Any potential for long-term survival would involve an almost unimaginable feat of engineering and resource management in a completely new, hostile environment, while simultaneously combating the cosmic radiation no longer shielded by the Earth's magnetic field and atmosphere. Humanity, along with all other life on Earth, is intrinsically tied to the existence of gravity and the planetary stability it provides. Our existence is a direct consequence of its ceaseless pull. Without it, life as we understand it would simply cease. The disappearance of gravity would not merely be the end of life on Earth. It would be the beginning of the end for the universe as a structured, coherent entity. The elegant cosmic dance, the formation of stars and planets, the very reason for our existence, all hinge on this one fundamental force. Without gravity, the universe would slowly and silently unravel, reducing the majestic tapestry of galaxies and stars to a scattered, ever-expanding dust cloud of isolated particles, drifting endlessly into the void. A testament to the essential, often unseen power that quietly holds everything together. Thanks for watching. Please subscribe my YouTube channel for more interesting videos. Citations, asterisk, what if gravity suddenly disappeared? How Stuff Works. Access September 4, 2025. Self-correction. While How Stuff Works is a source, it's better to cite more authoritative sources if possible for scientific claims. However, the speed of Earth's orbit is a well-established scientific fact. Einstein's general theory of relativity, NASA. Access September 4, 2025. Self-correction. While NASA is an excellent source, it's a broad topic. I will assume this is general knowledge about general relativity.